In this video, you will learn how to divide monomials. Now, to divide monomials, we need to understand the property of quotients. So the property of quotients in math notation says that if a, b, c, and d are real numbers, assuming b and d are not zero, then ac over bd equals a over b times c over d. So all that means is that if you have everything being multiplied together on the top and then two numbers multiplied together in the bottom of a fraction, I can break it up as a product of two different numbers. So for example, let's say we had 14 over 21. All right, well 14 I can think of as 2 times 7, and 21 would be 3 times 7. So this property of quotients says that when you have this type of setup, where on the top and bottom both you have multiplication, you can break apart the fraction as two different fractions, where I'd have 2 over 3 times 7 over 7. And that's important because from here, 7 over 7 is just 1, so we have 2/3 times 1, which is 2/3. So this concept is important in order to simplify fractions, and that's the objective of the lesson. All right, so in short, if b, c, and d are real numbers with b and d not equaling 0, then bc over bd equals c over d. So bottom line, what this is saying is if you see two numbers in common, so a number on the top and the bottom, I can simply divide those out. I'm left with just c over d. And that's what we see over here. We had 2 times 7 over 3 times 7. They both had a 7 on the top and bottom, and it's all being multiplied together. 2 times 7, 3 times 7. So the 7s can just divide out, and I'm left with my answer of 2 over 3. So either way you want to think of it, you will get the same solution. So when you have variables thrown in there, or if it's just numbers, you can use either of these thought processes to simplify. So here are a couple examples. First, we see 25 over 30. So if I wanted to, I can think of 25 as 5 times 5, and 30 is 5 times 6. So here, because they both have a 5 in common on the top and bottom, everything is being multiplied on the top and the bottom as well, we can simply divide the 5s, and we have 5 over 6, which is my answer. Okay, next we have 22 over 33. 22 would be 2 times 11. 33 is 3 times 11. I can divide the 11s out, so I'm left with 2 over 3 as my solution. Okay, 12 over 22. 12, we can think of that as 2 times 6. 22 is 2 times 11. I can divide the 2's, and I'm left with 6 over 11. Now, we can break it apart like this, or it's easier if you just take the fraction that you see and try to find the greatest common factor of the two numbers, so of 25 and 30, or of 22 and 33, and then divide both by that. So for example, the greatest common factor of 25 and 30, as we learned in the previous lesson, we can calculate, and that would be 5. So I can divide 25 by 5 to get 5, and divide 30 by 5 to get 6. All right, so that's a quicker way of doing that. Instead of breaking it apart like this, you can just find the greatest common factor and divide top and bottom by that number. So there's two ways to think of it. Either break it apart and then cancel, or you can simply find the greatest common factor and then divide by that. Another example, we have negative 5xy over 10 times x. So if I wanted to break the 10 apart, I could think of that as 2 times 5. And I did that because I see the 5's would cancel. Right? 5 and 5 would cancel out. The x's would also cancel out. So I have negative and y over 2. So the negative could go on top with the y, or it's probably better to write it here on the side of the fraction, like this. So you have negative y over 2. And that is the same thing. And once again, we could have just looked at the 5 and 10 and see that they both have a 5 in common. So I could just divide both by 5. So divide the 5 by 5 to get 1. The 10 divided by 5 would give me 2. So I'd have negative 1y over 2 times x. Or sorry, over 2. The x is canceled. So negative 1y over 2. Okay, next we see a few more examples. So here we have c to the 8th power divided by c to the 5th power. And there's different ways you can think through this problem. All right, so the way we just discussed with this quotient property is I can break apart the c to the 8th power as c to the 5th power times c to the 3rd power, and that's divided by c to the 5th power. So I see here they both have c to the 5th in common. I can divide those out, and I'm left with c to the 3rd power. For example 7, we can do the same thing. We can break down the a to the 5th power to match up with the top. So the a to the 5th power I can break down as a squared times a to the 3rd, so that now the a squareds will cancel. So now I have 1 on the top over a to the 3rd power on the bottom. And then lastly, example 8, we see here they both have c to the 4th on the top and the bottom. So those would divide out right away, and that would give me 1 over 1, which would equal 1. And we know that anything divided by itself is 1, so I can see right from here that this would equal 1 because we have the same thing on the top and the same thing on the bottom. Now when you have variables like this, there's really not a need to have to break it apart as we did here, because there is a shortcut we can do. And that is based off our rule of exponents for division. So we see here what we need to do. So what we do is we simply subtract the exponents. So when we divide, we subtract the exponents. All right, so here we have y to the 8th power over y to the 3rd power. What we do is we want to subtract 8 minus 3 to get 5. So this would be y to the 5th power. Now what if you had x squared over x to the 6th power? Well, here, if we subtracted 2 minus 6, we would get a negative exponent, which is a real thing. We could have negative exponents. And that would be 2 minus 6, which is negative 4. So you could write that as x to the negative 4th power, but it's better to write it without a negative exponent. So there's times when you want the negative, but many times you do not want the negative exponent. So what I can do to make it not negative is if this top number is smaller than the bottom number, or the other way of thinking of that, if the bottom is bigger than the top, then I can write that as 1 over, and then subtract 6 minus 2 to get x to the 4th power on the bottom. All right, so if it's going to be a bigger number in the bottom, your exponent is going to go in the bottom. All right, and the other way of thinking of that is if we had x squared, that is the same thing as x times x. X to the 6th power would be 6 x's on the bottom. That's 5, 6. So if I use my rule for quotients, property of quotients, I can divide what they have in common. So those would cancel. That would cancel with this. So what I'm left with is 1, right? 1 over x to the 4th power on the bottom. So my answer is 1 over x to the 4th power. Okay, and then example 11, if you have the same number, the same exponent, we would have just 1, because anything divided by itself is 1. Another way we could think through that is same idea where we subtract the exponents. 4 minus 4 would be 0, so x to the 0 power would equal 1. And that's because anything to the 0 power is 1. Now lastly, we're going to put this all together. So let's say we had numbers and variables on the top and the bottom, and you're told to simplify this. So there are different ways you can think through this, but the easiest way probably is to begin with the numbers, so 42 and 35. So looking at the numbers, I need to find the greatest common factor so that I can divide the top and the bottom by that. So looking at the two numbers, I see that I can divide both by a 7. So 42 divided by 7 would give me a 6 on the top. And 35 divided by 7 would give me a 5 on the bottom. So far, I have 6 on the top, 5 on the bottom. So now the question is, with the variables, what do I do? So looking at the x's, we have x to the third over x to the 6th power. So the number in the bottom is bigger. So either way, I'm going to subtract, right? I'm going to subtract the bigger by the smaller. So I can do 6 minus 3. That gives me 3. And the exponent goes in the bottom because this exponent down here in the bottom is bigger. X to the 6 is bigger than x to the third. So when I divide, I have x to the third in the bottom. Looking at the y's, we have y to the 4th power divided by y squared. So when I divide, I subtract the exponents, 4 minus 2 to get 2. So it's going to be y squared, and the question is, does it go on the top or the bottom of the fraction? Well, it goes on the top because y to the 4th is bigger than y squared. 4 is bigger than 2, and 4 is in the top, so y squared, when I divide, is going to be in the top as well. And then the z's, we have z to the 1st power over z to the 3rd power. And if it's not written, it's an assumed 1, so that's a 1 there. And then when we divide, we subtract the exponents. So we do 3 minus 1 to get 2, so it's z squared. And the question is, does it go on the top or on the bottom? Well, it goes on the bottom because the 3 is bigger than 1 and 3 is in the bottom. So my answer will go in the bottom as well. So my final answer would be 6y squared over 5x to the third times z squared. Now, what if the numerator of the fraction had more than one term, such as 10x squared minus 5x plus 15, then divide all of that by 5? Well, using my law of fractions, I can separate this into 3 different fractions, where I have 10x squared over 5, negative 5x over 5, and the plus 15 over 5. So I broke it up into 3 separate fractions, and from here I can do the same thing that I just did. So for the first term, 10 divided by 5, that's going to give me 2. And then second term, 5 divided by 5 would give me 1. And third term, we have 15 divided by 5, that gives me 3. So I have 2x squareds minus 1x plus 3. Here's one more example. Now we have 4a squared b cubed plus 8ab to the 4th minus 20ab squared all over 2ab squared. Now again, because of the plus and minus signs on the top, I can break this up into 3 separate fractions, where I have 4a squared b cubed over 2ab squared plus, second fraction is 8ab to the 4th over 2ab squared. In the third fraction, we have minus and then 20ab squared over 2ab squared. So when I divide this first fraction, 4 divided by 2 would give me 2 over 1. And then the a squared over a, I can subtract the exponents. 2 minus an assumed 1 gives me a to the 1st power, and that goes in the top because the numerator had a bigger exponent. And then b cubed divided by b squared, so 3 minus 2 would give me 1, so I have b to the 1st power in the top here as well. So this first fraction simplifies to become 2 times a to the 1st times b to the 1st, or 2 times a times b. Second fraction, 8 divided by 2 would give me 4 over 1. So we have 4, and then a divided by a would cancel out. B to the fourth divided by b squared. I can subtract the exponents, 4 minus 2, to get b squared, and that goes in the top because the 4 was bigger and was in the top. So what I have there is 4 times b squared. Then minus this third term, we have 20 divided by 2, gives me 10. ab squared divided by ab squared would cancel out completely. That leaves me with just a 10. So my final answer when I divide is going to be 2ab plus 4b squared minus 10.